Good evening. For my presentation, I will be discussing about small cell networks. For my presentation, I will be discussing the importance of small cell networks. But before I get into the very functions of these small cell networks, I'll be discussing a bit about their entire buildup. What is a small cell? Small cells are low-powered cellular radio access nodes that are operating in licensed and unlicensed spectrums that have a range of 10 meters to about a few kilometers. The cell main objective is to solve network capacity issues in small areas. By building one could supply air interfaces including GSMs, CDMA 2000s, TD, CDMA, WCDMA, LTE, and WiMAX in small areas. These devices are small and cheaper to build than creating a brand new microsite. These microsites can be identified and seen in the outskirts of town or in rural areas. These are usually large antennas constructed in secure locations, private locations owned by the state or government. Because of their sheer size, it is usually expensive to maintain them, as well as the power source they require in order for them to process or do the job they're made for. Usually these antennas are very large, very tall. You can see them from miles away, which is why it's recommended that they're being built in areas where it's less populated. Now, the direct opposite of the microsite is the phantom cells. Phantom cells, or phantom cells as pronounced here, are small cellular telecommunication base stations that can be installed in residential or business environments, either as a single standalone item or in clusters to provide improved cellular coverage within a building. In this case here, these are usually identified as small routers or modems placed into certain areas of a home or into a business. As we discuss further on how the small cell network works, it will be multiple cellular towers or attached to light poles scattered around an entire small community or small city to give a much more better range than that of a macro cell. By using small internal base stations, phantom cells, the circuit performance can be improved along with the possible provision of additional services. These phantom cells are just extenders of what the macro cell can do, where one macro cell is equivalent to about 100 of the phantom cells, able to give the same amount of range and the same amount of information and data processing as one large macro cell site. Here's a distinctive difference between the various size of a macro cell and a phantom cell. You have obviously seen the image to the left as a macro cell. Very large antennas on private property, usually gated, with a single building that controls the very operations of these towers. These towers are very large and obviously can be seen from miles depending upon which company and how the tower is made. Versus the phantom cell to the right, which is usually used as either a modem or a local access point that you see either in cafes or on the streets or in the lamppost. Now, 100 of those phantom cells could obviously have the same amount of performance as one macro cell. Difference is the phantom cells could spread across in a small, busy residential and commercial area, whereas again, the macro cell would need to be in an rural area or in the outskirts of town where less amount of interference from, say, other people or less amount of interference dealing with crowded areas, traffic, where it might cause enormous amounts of radio pollution in a sense if there's too many antennas, which is the reason why for these macro cells you would only see one every few miles so that they won't collide with the radio frequencies of each other. Now, to get to the very core of my report is the macro cell, is the phantom cell or small cell networks. This is usually where you have multiple phantom cells in a particular city, such as one on every street corner that's either installed on a traffic light post or it is installed on an actual post by itself. Small cell network is used as a term to describe multiple phantom cells as a standalone pole or installed on small towers. Used instead of making large towers such as the macro cells before, and helps increase network capacity, expanding the coverage. With the macro cell in conjunction with the phantom cells, all they are extenders. But these phantom cells can perform the same functionality as a macro cell could. Here is a distinct description of how one is visually seen in comparison with each other. The tower versus the small cell towers. Tower obviously is very tall and visibly prominent, versus a small cell which is discrete, lower to the ground. As you see, the distinctive of the very differences in size, as well as how you would perceive to see these towers in a certain setting. You wouldn't see a large antenna tower such as the image to the left in major metropolitan cities, but more in country areas. Now, small cell networks are made up of small discrete nodes that sits closer to the ground. It's easy to walk right by them and not even notice. They're often attached to street lamp posts. Large towers require more power than the small cell towers. Now, obviously, one huge tower can probably give an entire city data transmissions, receiver, radio frequencies, able to provide even internet access based upon WiMAX, based upon the function of the tower itself. That would obviously require a lot of power versus having multiple small cells located on each street corner with a set specific range that you will only need one macro tower and a couple 100 small cell towers. Because of that, the power, the resources, the power, the energy source for these small cells may only require a couple AAA batteries just to keep it powered up, or in possibility, because of its sheer size, they could use solar panels instead to power them up. Now, towers are good for voice data signal and can degrade over distances. Now, as for small cells, on the other hand, this is where they pretty much are beneficial. Because you have multiple small cells in a particular area, they're simply sharing resources with one another. Therefore, you're not far away from one spot where a cell is generating data transmission or voice or radio frequencies. You simply are about at least a couple feet away from one small cell's network tower versus having a large tower where the further away from the tower, the worse the signal gets. Now, why small cell networks are important? One and foremost is the fact that the cost of these small cell networks. The macro cell may cost about, say, around $100,000 to $200,000, depending on what purpose that tower is used for. Whereas small cell network towers are the size of simply a modem purchased from either Comcast or AT&T that has Wi-Fi capabilities. The difference is to increase the bandwidth as well as the frequency range of these phantom cell towers, these small cell towers. And of course, the cost for them are no more than about $200 a piece. So by making 100 of these in a particular area, they could potentially match the same amount as a tower, as a macro tower, and the site of the macro tower. The amount of energy required, as mentioned before, you could possibly make an amount of solar panels to power these up. Now, solar panels have been seen on many lampposts, and in fact, they've been used on some cameras in certain areas of this city we live in right now. So, you could use solar energy to power these small cell towers versus where you have to put a generator on these large towers, which will obviously cost a lot of money as well as monthly cost to maintain it. And obviously, the fact that when you have multiple phantom units on every corner, they will perform the same way as a macro tower because they're all sharing the same resources. that is one of the functionalities of the small cell networks. And the fact that you can install these virtually anywhere or have a pole which is not going to be obscured to the visual prowess versus having a large tower in the middle of the city or the very edge of the city where people will not get the benefit of it. Now, I will discuss some of the articles relating to the reasons why I think that small cell networks are important to have for the next following slides. Hierarchy Resources Allocation Framework for Hyperdense Small Cell Networks. Solving an issue dealing with performances of data transmissions within multiple cell networks is an issue. If we were to use these in a more aggressive manner rather than in small, normal residential areas, and we were going to use these in a huge metropolitan area, obviously there's going to be a lot of traffic of data going back and forth. In this case here, it would need better performance, as this article will go further in describing what this performance is and what are the techniques used for it. Commercial video caching system for small cellular networks using game theory. The fact that the network needs to be one hive mind. Each small network node will have to share the resources of the previous one or the one closest to it. By that reason, which proves by my older slide before, how one tower, if you're further away from it, you will lose a good amount of data rates or data signal or signals, versus if you were to be around 100 of these small towers here, your signal strength will never go down, obviously because of the range of one next to the other. But if you were to be downloading something from a different node, a different small tower node, it will be the exact same thing, which means you constantly drive down an entire roadblock and not lose that data transmission rate or whatever you were installing or downloading via mobile device, phone, or whatever that might require to be, or what's considered to be the Internet of Things device. Secure full duplex small cell networks in a spectrum sharing environment. Now, the ability of the full duplex is a new feature used in the 802.116 framework. The fact that you're able to make multiple transmissions, large transmissions on a very large scale. This is based upon the fact that instead of using asynchronous type of data transfer rate, it's simply putting that you're able to make numerous amounts of huge amounts of data transmission rates back and forth without any issues. Because of this, that must be a way to protect it so it doesn't have any future problems. This article will fully discuss this in a way where it will be beneficial in a small cell network versus a microcell network, versus a microcell site, even though the microcell site will be required for this to work as intended from this article. Last will be the power allocation for cache-aided small cell networks with limited backhaul. Sharing of power resources and using alternatives to generate energy from multiple small networks, which should be similar to what I discussed before about the solar panels. This will discuss about what other alternatives, as well as any backup plans in case there was a lack of power needed. This concludes my presentation of small cell networks. My name is Shane Houghton, and have a good evening.